Hi friends, this is Chetanade working as an assistant professor in MIT College of Railway Engineering and Research Barshi. Now this is second video regarding with this second chapter Fourier series. In previous video we are seeing that what is the definition, some basic formulas, some of the important result we are seeing in last video. Now on the basis of this interval 0 to 2 pi we have to solve this example. How to solve this example we will see one by one. Now this is the example. Find the Fourier series function of f of x where f of x is equal to x square in the interval 0 to 2 pi. आपल्याला ह्या इंटरवल मध्ये ह्या फंक्शनचं फोरियर सिरीज एक्सपेन्शन फाइंड करायचं. मग we know that Fourier series is given by f of x is equal to, what is the f of x is equal to, what is the formula? A naught plus summation n running from 1 to infinity a n into cos nx plus summation n running from 1 to infinity bn into sin nx. Okay, we have to find the value of a naught, a n and bn. That is called as a Fourier coefficient, and we have to find this value a naught, a n, bn by using Euler's formula. And we know that in previous video we are seeing that how to find that value. Now what is the value of a naught? A naught is equal to 1 upon 2 pi integration 0 to 2 pi, that is the range of this interval 0 to 2 pi f of x into dx, okay, which is equal to this 1 upon 2 pi as it is. Now this integration 0 to 2 pi is also as it is. Now we know that the value of f of x, what is the value of f of x? X square into dx. Now by using the result integration of x raised to n into dx is nothing but x to the power n plus 1 divided by n plus 1. Okay, this 1 upon 2 pi as it is, and the integration of x square is x cube upon 3, and the limiting value is 0 to 2 pi. Okay, now the next step, which is equal to 1 upon 2 pi, put the upper limit minus lower limit. This is nothing but 2 pi upon 3 bracket cube minus 0 cube divided by 3. Okay, now which is equal to 1 upon 2 pi into this 2 pi cube, okay, divided by this 3. This 1 2 pi and this 2 pi cube cancel with each other. This will remains with only. Therefore a naught is equal to, what is the value? 4 pi square upon 3. Okay, it remains with only, what is that value? 2 pi square upon 3, which is equal to 2 square is 4, pi square is pi square divided by 3. Therefore what is the value of a naught? A naught is equal to 4 pi square upon 3. Please remember this value, because at the end of this example we have to put all this value here. Now I am writing just for my simplicity, a naught is equal to 4 pi square upon 3. Now we get the value of a naught. We have to find the value of a n. But now what is the formula? A n is equal to 1 upon pi integration 0 to 2 pi f of x into cos nx into dx. Now this is formula. Okay, now we are familiar with this f of x. 1 upon pi is also as it is integration 0 to 2 pi. What is the value of f of x here? X square into cos nx into dx. Now we have to find the value of this integration by using Liat rule, L-I-A-T-E. This is algebraic function and this is trigonometric function. That's why this is my first function and this is my second function. By using the formula, what is that formula? Integration of u into v into dx, which is equal to, this is first function, this is second function. That formula is by using this result, this is first function, this is second function. First function as is integration of second minus integration of derivative of first into integration of second. We have to use this formula for finding this integration. Now this is my first function, this is my second function. This 1 upon pi is constant, taking outside the integration, and apply this integration for this. Now this x square as it is, this is nothing but first function as it is, into integration of second cos nx into dx minus integration of derivative of first d by dx of x square into integration of cos nx into dx. Okay, into dx, this total bracket complete. We'll put this limiting value at last of this area. Okay, now this 1 upon pi as it is, this x square is also as it is. Now by our result, what is the integration of cos? We know that integration is sine, आणि हा n कॉन्स्टंट आहे. इंटिग्रेशन मध्ये कॉन्स्टंट आपण डिवाइड करत असतो. ठीक आहे, मग ह्याचे इंटिग्रेशन काय येणार आहे? cos nx sin nx upon n. Okay, now minus integration of this d by dx of x square. What is the integration of, sorry, derivative of x square? 2x into, now again integration of cos nx. What is that integration? Sin nx upon n into dx. Okay, this step is now we have to find this 1 upon pi as it is into this x square into sin nx upon this n minus this 2 and n are constant, taking outside the integration 2 upon n. Now this integration of x into sin nx into dx. Now again we have used this formula for finding this integration. Okay, we have to use that formula, which is equal to 1 upon pi as it is in this bracket x square into sin nx upon n minus 2 upon n. Now we are using this product rule of integration for finding this integration. Apply this formula. First function as it is into integration of second minus integration of derivative of first into integration of second. Okay, this is our formula, which is equal to 1 upon pi in this bracket x square into sin nx upon n minus this 2 upon n as it is in this bracket x as it is. Now what is the integration of sin? We know that in the integration of sin is minus cos nx upon this n. Okay, integration मध्ये आपण constant divide करतो. This n is constant minus integration of derivative of x. What is the integration of derivative of x is 1, and the integration of sin nx is minus cos, minus this will becomes plus cos nx upon this n into this dx. Bracket complete, this total bracket is complete. Again for the next step, 1 upon pi as it is, this bracket x square into this sin nx upon n minus 2 upon n in this bracket minus x into cos nx upon n, this plus, now this n is constant, taking outside the integration, and integration of cos is sin nx upon n, and this n into n square, that value is sin nx upon n square. This bracket complete and this total bracket complete. Okay, now we have to find, now what we have to do, now multiply this minus 2 by n inside this bracket, we will get, which is equal to 1 upon pi in this bracket this x square into sin nx upon n. Now multiply this minus it will become plus 2x into cos nx upon this n into n is n square, and this minus sign it will become, this plus will becomes minus 2 sin nx upon this n into n cube. Okay, this is our total. Now we have to find just we have to put the limiting value 0 to 2 pi. Now we know that after putting we will get upper limit minus lower limit, we will get this our result for this perfect. Now put this 2 pi, जिथे जिथे x दिसतंय आपण तिथे 2 pi put करणार. ठीक आहे, 2 pi square into this sin 2n pi divided by n plus, this is my upper limit, plus 2 into 2 pi into this cos 2n pi divided by n square minus 2 sin 2n pi divided by n cube. Okay, this is my upper limit minus lower limit. इथे जेव्हा मी x ची व्हॅल्यू 0 पुट करेल तेव्हा ची व्हॅल्यू टोटल किती येणार आहे 0. सिमिलरली इथे पण पुट केल्यावर किती येणार आहे 0. Okay, this result is also 0, and after putting here sin 0 is again 0, means its lower limit is obviously 0. Now we have to calculate just this limit, okay, which is equal to 1 upon pi in this bracket. Now this sin 2n pi, we know that in first video we are seeing that sin 2n pi is 0. Okay, what is the value of sin 2n pi? 0. Again this plus 2 into 2 4 pi into this cos 2n pi. we know that the suppose this cos multiple even multiple of pi is always 1, that's why its value is 1 into 1 divided by this value ns square minus this sin 2n pi, we know that this value is 0, okay, and this lower limit is obviously 0. Therefore 1 upon pi into this 4 pi, this 4 pi into 1 again 4 pi divided by n square. This pi cancel with each other. Therefore an is equal to 4 upon n square. This is the value of our en. Just for simplicity we are writing here an is equal to 4 upon n square. Okay. Now we have to calculate the value of bn, which is equal to, we know that the formula 1 upon pi integration of 0 to 2 pi f of x into sin nx into dx. This is our formula. Now put the value of f of x here, which is equal to 1 upon pi integration 0 to 2 pi. What is the value of f of x here? X square into sin nx into dx, which is equal to, now again by Liet rule we will get how to find that. This is by using this formula. We are finding the integration of this term first function as it is into integration of second minus integration of derivative of first into integration of second into this dx. Okay, this is very simple. Just एकदम पेशन्सली आपण सावकाश सोडवत गेलो ना आपल्याला हे इंटिग्रेशन इझिली सॉल्व करू शकतो आपण. ठीक आहे, 1 upon pi as it is. Now this x square as it is, we know that the integration of sin is minus cos and the constant divided by n. Cos, this minus as it is, cos nx upon n minus integration of derivative of x square is 2x into integration of sin nx is minus cos x, minus this will become plus cos nx upon this n into this dx. Okay, which is equal to 1 upon pi as it is. Now this bracket minus x square into cos nx upon this n plus this 2 and n constant taking outside the integration, and this x into cos nx into dx. Now we have to again apply here that formula in this next step. Okay, now again apply this formula for finding this integration. Again, this is my first function, this is my second function. Now apply this formula for finding this value. Okay, 1 upon pi as it is in this bracket minus x square into cos nx divided by n plus this 2 by n is also as it is, and apply this formula. First function as it is integration of second cos nx into dx minus integration of d by dx of x into integration of cos nx into dx. Okay, now this formula is here, which is equal to 1 upon pi as it is, this formula minus x square into cos nx upon n plus 2 by n is also as it is into this bracket. What is the integration of cos nx? Is again sin nx upon this n minus integration of derivative of x is 1 and integration of cos nx is sin nx, sin nx upon n into dx. This bracket is complete, total bracket is complete. Okay, which is equal to this 1 upon pi as it is in this bracket. Now this term minus x square into cos nx upon n. Now for this term plus 2 by n as it is in this bracket, this x sin nx upon this n. Now this, what is the integration of sin nx? Minus cos nx, minus it will becomes plus cos nx upon this that n and this n, it will becomes n square in this total bracket is complete. Now multiply this 2 by n under that bracket, 1 upon pi this minus x square into cos nx upon this n plus 2 by n 2x sin nx n into n, this n square plus 2 cos nx upon this n square into n cube, and the limiting value is 0 to 2 pi. Now put upper limit minus lower limit, 1 upon pi as it is. Now this upper limit minus 2 pi bracket square into cos 2n pi divided by n plus 2 into 2 pi into sin 2n pi divided by n square. This is upper limit. Okay, plus 2 into cos 2n pi डिवायडेड बाय n क्यूब मायनस, नाव पुट द लोअर लिमिट दिस, इथं ही व्हॅल्यू पुट केल्यानंतर इथं 0 च्या ठिकाणी x च्या ठिकाणी 0 पुट केल्यावर हे 0 होणार आहे. सिमिलरली इथं पण 0 होणार आहे आणि शेवटच्या ठिकाणी 2 cos 0 divided by n cube. Okay, this is my upper limit minus lower limit, which is equal to 1 upon pi in this bracket. Now this 2 pi square is nothing but minus 4 pi square into cos 2n pi is 1. Okay, divided by n as it is. Now this sin 2n pi is 0. That's why this term is also 0. Cos 2n pi is 1. This is nothing but 2 upon n cube. Okay, now this is upper limit minus lower limit. Its total value is cos 0 is 1 and this is 2 upon n cube, which is equal to, this total terms is become 1 upon pi as it is in this bracket minus 4 pi square divided by n plus 2 upon n cube minus 2 upon n cube. Okay, these two terms cancel with each other. Therefore, Bn is equal to 1 upon pi into this minus 4 pi square divided by n. This pi cancel with each other. Therefore, Bn is equal to minus 4 pi upon n. Okay. Now, आपण तीन सुद्धा व्हॅल्यू फाइंड केल्यात. ठीक आहे, ए नॉट फाइंड केला, an फाइंड केला आणि bn सुद्धा फाइंड केला. आता ह्या तिन्ही व्हॅल्यू आपण ह्या इंटिग्रेशन मध्ये पुट करूयात आणि बघूयात आपल्याला काय सोल्युशन भेटते ते. ठीक. Now put all these value of a naught, an and bn in this Fourier series expansion. F of x is equal to, this value of a naught is 4 pi square upon 3 plus summation over n is equal to 1 to infinity. What is the value of an? 4 upon ns square into this cos nx plus summation over n running from 1 to infinity. Bn is minus 4 pi upon n into this sin nx. This we know that the f of x is equal to x square. This is a Fourier series expansion of x square. Okay, this is very simple. बघा एक्झाम्पल आपण जेव्हा सॉल्व्ह करतोय तेव्हाच आपल्याला फक्त ठराविकच फॉर्म्युला वापरायचे. एक तर सगळ्यात महत्त्वाचा हा फॉर्म्युला cos 2n pi sin 2n pi cos n pi sin n pi. अशा व्हॅल्यू आपल्याला व्यवस्थित माहित पाहिजेत. ठीक आहे, फर्स्ट फंक्शन कुठलं, सेकंड फंक्शन कुठलं, एवढं एक माहिती पाहिजे. आणि दरवेळेस इथं फक्त काय होईल, x 2x x स्क्वेअर, इट मे बी लाईक x क्यूब, अशी फक्त फंक्शन बदलणार. बाकीचं तर आपल्याला दरवेळेस फर्स्ट फंक्शन ॲज इट इज, सेकंड फंक्शन ॲज इट इज, त्याचं इंटिग्रेशन काय, त्याचं डेरिव्हेटिव्ह काय, एक 5-6 फॉर्म्युले फक्त आपल्याला व्यवस्थित बघायचे. ठीक आहे, हे जर तुम्ही व्यवस्थित बघितलं आणि पेशन्सली वन बाय वन स्टेपने जर सोडवत गेला ना, तर तुम्ही सहज इझिली हे एक्झाम्पल सॉल्व्ह करू शकता. इट्स व्हेरी इझी. नाउ वी विल सी वन मोर एक्झाम्पल ऑन दिस आर्टिकल. ओके, दिस इज आवर सेकंड एक्झाम्पल on that interval 0 to 2 pi. Okay, what is that example? Find the Fourier series of f of x in interval 0 to 2 pi. This is our original range. What is that range? 0 to 2 pi. Now they are giving function f of x is equal to x when 0 to pi and f of x is equal to 2 pi minus x when pi to 2 pi. Suppose here is our 0, okay, and here is our 2 pi. This is our total range is there. And they are dividing the function like that 0 to pi. 0 to pi आहे तेव्हा फंक्शन काय डिफाइन केले त्यांनी, x, आणि पाय पासून 2 पाय मध्ये फंक्शन काय डिफाइन केले, 2 पाय मायनस x हे फंक्शन डिफाइन केले. आपल्याला फक्त काय करायचे, ओरिजिनल तर आपण ॲज इट इज तेच फॉर्म्युला वापरणार आहे. फक्त काय की रेंज त्यांनी डिवाइड केले, त्यासाठी फक्त अजून पेशन्सली थोडं सावकाश फक्त इंटिग्रेशन त्याचा फाइंड करायचं. ठीक आहे, बघूयात आपण आता. Now Fourier series expansion is given by, what is the Fourier series expansion? F of x is equal to this a naught plus summation over n running from 1 to infinity an into cos nx plus summation over n running from 1 to infinity bn into sin nx. Suppose we are calling it is an equation number 1. Okay, सेम प्रोसेस करायची. मागच्या एक्झाम्पल मध्ये जसं आपण a नॉट a and b n फाइंड केलं होतं आणि ते परत त्याच्यामध्ये पुट केलं होतं, सेम आपण ॲज इट इज प्रोसेस करणार आहे. काही सुद्धा फरक नाही आहे याच्यामध्ये. सेम फाइंड करायचं आपल्याला एक्झाम्पलच. फक्त काय की सावकाश फक्त रेंज फक्त ब्रेक केले, बाकी काहीच होत नाही. बघूयात आपण आता कसं फाइंड करायचं. ठीक आहे. फर्स्ट ऑफ ऑल ए नॉट इज इक्वल टू, नाउ दिस ए नॉट ए and b and are Fourier coefficient, and we are calculating that a naught a and b and by using Euler's formula. Now a naught is equal to 1 upon 2 pi integration 0 to 2 pi f of x into dx, okay, which is equal to this 1 upon 2 pi as it is. Now we are giving the bracket for this because they are dividing this total interval into that range. First of all, integration 0 to pi f of x into dx plus integration pi to 2 pi into f of x into dx, okay, this is our range, which is equal to this 1 upon 2 pi as it is in this bracket integration 0 to pi. What is the function for this range? For this range, x into this dx plus integration pi to 2 pi. Now what is the function for this range? This 2 pi minus x into dx, okay, it is very simple. Now find the integration of this term, which is equal to this 1 upon 2 pi as it is for this bracket. What is the integration of this? Is x square upon 2. What is the range? 0 to pi, 0 to pi plus, now what is the integration of this 2 pi? 2 pi x minus, what is the integration of this x? X square upon 2. We are giving here separate integration, and it is possible if it here is subtraction or addition. Now what is the range? Pi to 2 pi, and this which is equal to 1 upon 2 pi in this bracket. What is the integration of x square? Sorry, by putting lower limit minus upper limit, this pi square upon 2 minus 0 plus this 2 pi into 2 pi minus 2 pi minus 2 pi minus 2 pi square divided by 2, okay, minus lower limit is 2 pi into pi minus pi square upon 2, okay, which is equal to this 1 upon 2 pi as it is, this pi square upon 2 minus 0 is pi square upon 2 plus, in solving this bracket, 2 pi into 2 pi 4 pi square upon, sorry, 4 pi square minus this is 4 pi square upon 2, this is nothing but 4 square into pi square upon 2 minus this is 2 pi into pi, this is 2 pi square minus this is pi square upon 2, okay, this bracket is complete, which is equal to 1 upon 2 pi as it is in this bracket pi square upon 2 plus, now this will becomes 4 pi square minus 4 pi square upon 2, this is nothing but 4 pi square upon 2, this is nothing but LCM काढल्यानंतर इथे होईल 8 pi square minus 4 pi square is nothing but 4 pi square divided by 2 minus, आता हे याला इकडे मल्टिप्लाय केलं, ह्याचा LCM काढल्यानंतर 4 pi square minus pi square is nothing but 3 pi square upon 2, okay, which is equal to this 1 upon 2 pi into this pi square upon 2 plus, now this 4 pi square upon 2 minus 3 pi square upon 2 is nothing but pi square upon 2. Now this pi square upon 2 pi square upon 2 which is equal to 1 upon 2 pi into, what is that value? 2 pi square upon 2. Now these two cancel with each other, this pi is cancelled with each other, therefore a naught is equal to pi by 2. This is our value of a naught, okay. Similarly we have to calculate a naught. We calculate the value of a naught is equal to pi by 2. Now we have to calculate the value of an, that is nothing but 1 upon pi integration 0 to 2 pi f of x into cos n x into dx, okay. Now we have to solve a very that is concentrated. We have to here integration 0 to pi f of x into, sorry, cos nx into dx plus integration of 0, sorry, pi to 2 pi that f of x into that cos nx into dx, okay. This is our range, which is equal to 1 upon pi this integration 0 to pi. For integration 0 to pi, what is that function? X into cos nx into dx plus this integration pi to 2 pi. What is the value of this for this range of f of x? 2 pi minus x into cos nx into dx. Now apply this formula for finding this both integration, okay, and this for both the integration limiting value are different, okay. Please see very carefully in 1 upon 5. Now solve this integration by using this formula. First function as it is into integration of cos nx into dx minus integration of d by dx of x into integration of cos nx into dx, okay. Now this is our first bracket, okay. For the second plus, now again apply this formula for finding this integration. 2 pi minus x into integration of cos nx into dx minus integration of d by dx of 2 pi minus x into integration of cos nx into ds. Okay, this bracket complete and this curly complete, which is equal to 1 upon pi as it is in curly bracket, okay, and this now in square bracket in this x as it is into what is the integration of cos sin nx upon n minus integration of day root of x is 1 and integration of cos x is sin nx, okay, it will becomes only sin nx upon n into dx. Now this first bracket is over plus, now for the second bracket this 2 pi minus x as it is into what is the integration of cos sin nx upon n minus integration of this derivative of 2 pi 0, derivative of minus x is minus 1, minus minus this will becomes plus, okay. Now the integration of cos is sin nx upon n into dx. Now this total bracket complete and this curly is complete, which is equal to this 1 upon pi as it is in this curly in this bracket, okay, this x into sin nx upon n. Now what is the integration of sin nx? Minus cos nx upon n into n, this n square minus minus this will becomes plus this cos nx upon n into n square. And what is the range for this integration? What is the range for this integration? 0 to pi plus, now this 2 pi minus x into this sin nx upon n. Now this, what is the integration of sin? Minus cos, minus minus, this will become plus minus minus cos nx upon n into n square. And what is the range for this integration? Pi and 2 pi, okay. Now put here upper limit minus lower limit, which is equal to this 1 upon pi as it is in this curly. Now this upper limit minus lower limit, after putting here pi into sin n pi divided by n, okay, plus cos n pi divided by n square, okay, this is upper limit. Now by putting lower limit, इथे ही व्हॅल्यू काय येणार आहे 0, ओके, इन दिस लोअर लिमिट 0 प्लस cos 0 upon n square, this bracket complete, this curly complete plus, now after putting here plus किती व्हॅल्यू पुट करताना आता बघा इथं 2 pi minus 2 pi, ओके, 2 pi minus 2 pi into this sin 2n pi divided by n minus इथं cos 2n pi divided by n square, okay, this is our upper limit. And now for this lower limit by putting pi minus, okay, minus this, sorry, ह्याची लिमिटिंग व्हॅल्यू आपण पुट केली. आता ह्याची लिमिटिंग व्हॅल्यू पुट करताना बघा इथे लिमिटिंग व्हॅल्यू पुट करताना इथे व्हॅल्यू जेव्हा आपण पुट करतोय 2 pi minus 2 pi ही व्हॅल्यू किती येते 0, ओके, दिस 2 pi minus 2 pi into sin 2n pi divided by n minus cos 2n pi divided by n square. Now this minus lower limit इथं पुट करताना बघा 2 pi minus pi into sin n pi divided by n minus again here cos n pi divided by n square. Okay. Now finding all this value, we'll get 1 upon pi as it is in this curly. We know that the sin n pi 0, cos n pi is minus 1 to the power n square. Okay, this value is 0 plus this value is minus 1 to the power n divided by n square. Okay, minus this cos 0, again we know that that value is 1. Cos 0 is 1 upon n square. Now this, okay, we solving this bracket plus again 2 pi minus 2 pi 0. Okay, this value is again 0. Again minus cos 2n pi is 1 upon n square minus for this 2 pi minus 2 pi is pi, and sin n pi is 0 minus cos n pi is minus 1 to the power n divided by n square. Okay, which is equal to 1 upon pi as it is in this result. This will becomes minus 1 to the power n upon n square minus this will become minus 1 upon n square. Okay, this will becomes minus 1 upon n square, and this will also become minus 1 is plus minus 1 to the power n upon n square. Okay, ही लेटर मी as it is आली, हे यात मध्ये मल्टिप्लाय केल्यावर हे मायनस होणार आहे, मायनस 1 upon n square, इथं मध्ये प्लस चं चिन्ह आहे, 0 minus 1 upon n square is minus 1 upon n square, मायनस मायनस हे दोन्ही काय होणार आहे प्लस मायनस 1 to the power n upon n square. ठीक आहे, आता ही टर्म किती वेळा माझी 2 वेळा. ठीक आहे, which is equal to 1 upon pi into this bracket 2 into minus 1 to the power n upon n square, and this term is also 2 times, that way this will become 2 into 1 upon n square. ठीक आहे, ह्या दोघांना आपण 2 कॉमन घेऊ शकतो, therefore an is equal to 2 जेव्हा कॉमन गेला आपण 2 upon pi आणि n स्क्वेअर सुद्धा कॉमन घेऊ शकतो. ठीक आहे, काय आपण कॉमन घेतले 2 upon n स्क्वेअर कॉमन घेतले आपण, मग इथे काय राहणार 2 upon n स्क्वेअर बाहेर घेतलं, इथे राहते minus 1 to the power n आणि इथे राहते फक्त 1. ओके, दिस इज व्हॅल्यू ऑफ आवर an, दिस इज नथिंग बट आवर an. इट्स व्हेरी व्हेरी सिंपल. ठीक आहे, सिमिलरली आता आपल्याला bn ची व्हॅल्यू फाइंड करायची, दिस इज आवर an. ओके, we are calculating the value of a naught and an. Now we have to calculate the value of bn, that is nothing but which is equal to 1 upon pi as it is in this bracket. For this integration 0 to pi f of x into sin nx into dx plus integration of pi to 2 pi f of x into sin nx into dx. Okay, this bracket complete and this curly is complete, which is equal to 1 upon pi as it is in this curly in this bracket, which is equal to integration 0 to pi. For this range, what is the function? X into sin nx into dx plus integration pi to 2 pi. For this range, what is that function? 2 pi minus x, 2 pi minus x into sin nx into dx. This bracket complete and this curly is complete, which is equal to 1 upon pi as it is in this curly. Okay, applying this formula for finding this integration, and this range is 0 to pi. Now this first function as it is, okay, into integration of second sin nx into dx minus integration of d by dx of x into integration of sin nx into dx. Okay, it's completed. Plus applying this formula for finding this integration. Now for this, which is equal to first function as it is into integration of second into dx minus integration of d by dx of 2 pi minus x into integration of sin nx into dx. Okay, now solve this integration, we'll get our next step 1 upon pi this bracket. Now this x as it is, okay, this bracket as it, this x as it is into this, what is the integration of sin? Minus cos nx upon n, minus cos nx upon n minus integration of, what is the derivative of x? Is 1, and what is the integration of sin nx? Minus cos nx, minus minus this becomes plus, plus cos nx upon n into dx. This bracket complete. Now this plus in this bracket. Okay, these total terms are over. Now we have to deal with this bracket. Now this 2 pi minus x as it is. Now what is the integration of sin? Minus cos nx upon n minus. Okay, this term is over. Now this minus as it is. Okay, minus as it is. Integration of derivative of 2 pi 0. A derivative of minus x is minus 1, and integration of sin x is minus cos x, minus minus, this will become plus cos nx upon n into this dx. Okay, this bracket is completed, which is equal to 1 upon pi in this curly, in this bracket, minus x into cos nx upon n plus, what is the integration of cos? Sin nx upon n into n square, sin nx upon n square. This bracket is over now, plus, now in this bracket, minus 2 pi minus x as it is into this cos nx upon n is also as it is, this minus n. What is the integration of cos? Sin nx upon n into n square, sin nx upon n square. This bracket is complete and this curly is complete. For this bracket, what is the range? 0 to pi, 0 to pi. And for this bracket, what is the range? Pi to 2 pi, pi to 2 pi. Now put here upper limit minus lower limit, we will get our required result, which is equal to 1 upon pi, this curly in this bracket. Now this upper limit here, minus pi into cos n pi divided by n. Okay, minus pi into cos n pi divided by n plus sin n pi divided by n square. This is my upper limit minus lower limit. By putting here, this will become 0. Again, sin 0 is 0. Upper limit minus lower limit. This total bracket is over. Now for this second bracket, plus here upper limit here 2 pi minus 2 pi minus 2 pi minus 2 pi into cos 2n pi divided by n minus this sin 2n pi divided by n square, upper limit minus lower limit. By putting here minus of 2 pi minus pi into cos n pi divided by n minus here is sin n pi divided by n square. Okay, this is our result, which is equal to this 1 upon pi as it is in this bracket. Okay, now this cos n pi, what is the value of cos n pi? Minus 1 to the power n, minus 1 to the power n into this minus pi divided by n, sin n pi is 0. Okay, now this total value is also 0 plus for this bracket 2 pi minus 2 pi is 0, sin 2n pi is also 0, 0 minus 0 minus, now this 2 pi minus pi, what is that value? 2 pi minus pi, 2 pi minus pi is pi, here is minus of pi into cos n pi minus 1 to the power n divided by n, and this sin n pi is 0 minus 0. Okay, which is equal to this 1 upon pi as it is in this bracket. Now this minus 1 to the power n into pi divided by n, this total value is this 0 plus 0, this minus minus, this will becomes plus pi into minus 1 to the power n divided by n. Okay, this negative and this value is positive, that's why this addition is 0, which is equal to 1 upon pi into 0. Therefore bn is equal to 0. Now put this value of a dot, an and bn in equation number 1 is nothing but we are finding all the values of that Fourier constant a naught, an and bn, where the value of a naught is this pi by 2, value of an is 2 upon pi n square in the bracket minus 1 to the power n minus 1, and the value of bn is 0. Okay, now put all that coefficient, Fourier coefficient in this our Fourier series expansion, standard Fourier series expansion. F of x is equal to a naught plus summation n running from 1 to infinity an into cos nx plus summation n running from 1 to infinity bn into sin nx. Put all this value in this expression. Okay, we will get this a naught pi by 2 plus this summation n running from 1 to infinity. What is the value of an? 2 upon pi n square in the bracket minus 1 to the power n minus 1, bracket complete, plus value of bn is 0, that's why this total term is 0. This is nothing but our Fourier series expansion of this function. Okay, this is very easy. Please try to understand. If you have any problem, then you can ask me anytime in comment box. Now we are move towards our homework example. A first example is there. Find the Fourier series expansion of पाय मायनस एक्स डिवाइडेड बाय 2 ब्रॅकेट स्क्वेअर. ओके, ह्याचं इंटिग्रेशन व्यवस्थित फाइंड करा. पहिले एक्झाम्पल आपण एक्स स्क्वेअर घेतलं होतं, इथं काय फक्त पाय मायनस एक्स अपॉन 2 ब्रॅकेट स्क्वेअर. ठीक आहे, त्याची रेंज तर ऑब्विसली दिलेली, काय कट वगैरे करायची गरज नाही, रेंज ऑब्विसली दिलेली आहे त्यांनी. आणि हे काय, दिस इज नथिंग बट आवर पिरियडिक फंक्शन, इट्स पिरियड इज 2 पाय. Now second example is there, f of x is equal to minus pi. This is constant, nothing to we have to, it's very simple. Minus pi and this x minus pi. Minus pi when it's minus pi 0 to pi साठी, and this range is pi to 2 pi, that function is given x minus pi. Now the third example is there for homework, which is equal to a when 0 to pi and minus a when पाय टू 2 पाय. दोन्ही सुद्धा कॉन्स्टंट आहेत, इंटिग्रेशनच्या बाहेर येणार आहे. सिंपल इंटिग्रेशन आपल्याला फाइंड करावं लागणार. एकदाच सहजासहजी ह्या 3 एक्झाम्पलची उत्तर तुम्हाला भेटून जातील. तरी सुद्धा तुम्हाला काही अडचण आली तर तुम्ही मला कमेंट बॉक्स मध्ये विचारू शकता त्याचा आन्सर. ठीक आहे, जर तुम्हाला काय अडचण आली तर तुम्ही कमेंट बॉक्स मध्ये मला कधीही विचारू शकता, कधीही मी तुम्हाला ह्याचा सोल्युशन देण्याचा चांगला प्रयत्न करेन. ठीक आहे, आणि हा व्हिडिओ पाहिल्याबद्दल thank you very much for watching my video. Still, if you are not subscribing my channel, please like, subscribe and share. Thank you very much. Thank you.